Hello, my name is Richard Collins, and I would like to show you some work that I did about 10 years ago. I was looking at the global network of superconducting gravimeters, and I wanted a way to calibrate them that would be simple and fairly straightforward to use. The idea I had was to use the Jet Propulsion Lab ephemeris to calculate the positions of the sun and the moon and the earth and the station locations, and calculate the tidal acceleration, or the gravity signal as I think about it, at the station that would match what the gravimeters were measuring. This, I don't know if you can see it on here. There's a little tiny bit of blue at the end of these. The blue underneath actually is the actual signal from the station, Matsushiro, Japan. This is 30 days. This is minute by minute. The data set is fairly extensive. I've got data from these various stations. There's Wuhan, China. I haven't looked at that just now. You can see the dates on here. I did this back in 2007. There's data up. I actually looked at it again as recently as 2013. Now I'll move that out of the way. This is just like I say, a 30 day piece of minute data. There are some 1 second data sets. I don't have an easy one to show you right now. If you're interested, I'll try to dig those out and see. I think for your purposes, actually, my original intention for doing this was to see if I could measure the speed of gravity this way. Unfortunately for me, I got lost in the complexities of just getting it done, and by the time I found a method that worked, I got distracted into the calibration and coordination issues more than trying to see if I could measure the speed of gravity. Just so you'll know, let's see if I can describe this. Basically, I took the position of the sun and the moon and the earth. I knew the masses. I calculated the gravity at the earth, the sun's gravity at the Earth's center. I subtracted or let's see if I can say this right. I took the sun at the station minus the sun at the center of the Earth. I took the moon at the station minus the moon at the center of the Earth. That's where this orange line comes from. And then basically it's a vector calculation. I put that into local vertical form. And to fit this curve in here only requires an offset and a multiplier. The G factor is the calibration number from the gravimeter itself. I can show you the derivation of that. It comes from the equipment calibration. This multiplier is just a simple multiplier to scale the signal up or down, and you might recognize the numbers approximately for Earth responses. I don't know that much geophysics actually, so I can't tell you all those things. And then this offset here. So I just I hope this might be of use to you to give you an idea what was involved in doing this. 10 years ago I was using Delphi, so unfortunately it's written in kind of an old language and maybe not one you're familiar with. Basically the core of the calculation is in here. The gravity at the Earth, from the Earth to the Sun, the gravity at the Earth's center from the Sun, the gravity at the Earth's center from the Moon, the gravity at, let's see, why did I do that? Oh, the gravity at the station from the Sun, the gravity at the station from the Moon. And then it's just subtractions then. I'm not going to go through this for you right now. There's a bunch of, vector conversions and calculations. The tedious part for me was, this part got easy. I mean, finding the station location took quite a bit of detail to get it right. I wanted to use a reasonable Earth shape. I wanted to I had to convert to the local vertical, that sort of thing. I had to, I found a decent Earth rotation calculation. So these are actually, I forgot I wrote them out here. The sun's acceleration at the center of the Earth, the moon at the center of the Earth, the sun at the station, the moon at the station, and then these tell. So it all I can say is that it works rather well, and it's easy. Once you can calculate the positions of the sun and the moon and the Earth from the ephemeris. This part is rather easy. I did hundreds of these, literally thousands. I don't know how many are in here. There's a good many of these files, and I didn't get them all. The second data at that time was a little bit too much for me to handle. I don't want to make this too long. I tried to keep this short. I also did. I thought it would be likely that I could take the seismometer data for long period seismometers, and that they should have the same signal in them. And it was much noisier, much more difficult, but I did find a way to do that as well for certain classes of seismometers. It took me several months to go through all kinds of different data. ISIS is the source for that, ISIS, and I got some reasonable results out of there. The idea I had at that time was, if you could, you have the gravimeters tracking this, you could sort of calibrate them as a group, and sort of use this as a common signal to tie things together. And then I thought, well, those long period seismometers could do the same thing, and maybe we could tie it all into a global network. I'm not in the geophysics field. Nobody knows me. This is just something I did because I thought it was interesting. I spent a couple of years at it. I thought it was it might be useful one day. Like I say, my original intention was to use it to measure the speed of gravity. I got lost in there trying to decide if the calculations of the of the positions of the Earth and the Sun were already retarded or not, and I couldn't find the information for it. Maybe you've looked at it fresh. Maybe you'll have a chance to understand, the nuances and dynamics of the Sun and Earth and how they fit into the equations. It seems like reading your paper, you managed to do that. And from my point of view, you're working with those tidal models, which are much, much more difficult to work with than this. And you got at least a starting result from it. I'm hoping, I don't know, the only reason I'm even doing this, I'm so old, I just, I'm long ago want to quit and move on with my life. But you're somebody who's trying, and I thought, well, it would be, if I could give you the benefit of something I spent a lot of effort on, maybe you could use this for something. And maybe not gravity. I mean, yeah, I saw you did some work. I did a little bit of Googling, and I saw you did some work on geophysical network data sharing, that kind of thing. So maybe you might have an interest in this. This stuff is archived out there. Here is the GGP home. Is eas.slu.edu/GGP, and the data should still be in here. These are the stations for the superconducting gravimeters. I showed you Matsushiro because they have pretty clean data, and actually the Japanese seismometer network is the one I used also. They were pretty good. I can't remember right offhand. Let me see. I didn't want this to be too long. Let's see. Oh, I've only got one in here. Let's see how bad. I only kept one regression. And yeah, don't even see. Pretty bad. Some of these, you see the signal in there because of the spikes. I didn't remove the spikes, and so the calibration went way off. And this is what but it seemed to me you could go in and chop out, some good sections of this, or just wipe out the spikes, and you could probably fit this one. In every case where I actually did that, I got good results. So I'm sorry, Wuhan, there at this point. This is what I was mostly working with, this kind of quality of data set. And this is the minute data. The second data is just like, right on. And I wish I had one to show you. Let me know. I don't want to make this too long. I hope it's of some use. My name again is Richard Collins. My email address is richardcollins@theinternetfoundation.org. That's the THE internetfoundation.org. And I have these all archived, everything. So if you have any interest in it, I'd be glad to send you what I have, if it would be of any use to you. I expect all of it still works. I'm pretty methodical when I put things away. So anyway, hope that helps. Thank you.